So again, yesterday we didn't really get to do the ones with 3 fractions. So go ahead and copy this one on your notes. Let me dim the lights. Okay, so we got 4 over x minus 2 plus 3 over x plus 2 equals 6 over x plus 2. All right, so the process is the same as it was on Tuesday. We just need to find the LCD and then multiply each fraction by the LCD. So this time we have 3 fractions. So we're going to have to multiply 3 times, okay? So for the LCD, remember you're looking at the denominators and see, can you factor anything? X minus 2, I can't do anything. X plus 2, I can't do anything. X plus 2, I can't do anything. So for LCD, it's just what do they have in common? Well, I can see that there's an x plus 2 in common. So I'm going to write that one once. And then whatever's left over, the x minus 2, you just attach it to it at the end. Okay? So x plus 2x minus 2 would be their LCD. Our excluded values is x cannot equal whatever would make these 0. So basically switch the sign. That's positive 2, so excluded value would be negative 2. And then for the second one is a negative 2, so switch the sign to a positive 2. Okay? So then our next step was to multiply by the LCD, but this time I have 3 fractions. So I'm going to multiply by the LCD to this one, multiply by the LCD, and multiply this by the LCD. Okay? We're going to multiply all 3 of them. You can rewrite it into like 3 different fractions, but I'm just going to use brackets here to show that I'm going to multiply both of them by the LCD. So my LCD is x plus 2 times x minus 2 over 1. And I have to do the same thing on the other side. So on the other side, I have x plus 2, x minus 2 over 1. All right, then when you multiply, the whole point of multiplying is to get rid of the denominators. So if I look at just this part here, I'm going to ignore the other side of the fraction. After the plus, I'm going to ignore that. If I do this here, what's going to cancel in my denominator? I get x minus 2. So this is going to go away with this x minus 2. So then I'm going to be left with 4 times x plus 2. Okay? I'm just not going to cross it out from the blue one because I'm going to need it again for the second one. But the x minus 2 is going to cancel. I'm going to be left with 4 times this x minus 2 cancels. So I'm left with the x plus 2. Okay? So I'm going to do the same thing now with the 3, x plus 2. So I'm going to ignore this. Just ignore this one now because we already did that one. But for the second one, x plus 2 cancels with this x plus 2. So then I'm left with 3 times x minus 2. So plus 3 times x minus 2. Okay? Again, you ignore the middle one because we already did this one. So ignore this one. Cancel the x plus 2 with this x plus 2. So you're left with 3 times x minus 2. And then that equals on the other side. On the other side, I can cancel. X plus 2 cancels out with this x plus 2. So I'm left with 6 times x minus 2. Okay, so notice this time I have like 3 binomials with a number in front of it. So we have to distribute for all 3 of those, okay? So I'm going to take the 4 times the x and 4 times 2. So that gives us 4x plus 8. And then do the same with the 3. Distribute the 3. So I get positive 3x. And 3 times negative 2 is negative 6. That's going to equal on the other side. I have 6 times x is 6x. And 6 times negative 2 gives you negative 12. All right, then I have a whole bunch of stuff going on here. I have this long strip of values. So I can see on this side, I have multiple x's and multiple numbers on the same side. So if they're on the same side, you have to combine them together, okay? So if I combine them, I have the 4x plus the 3x is going to give me 7x. And then I have like the 8 minus the 6 is going to be plus 2. I'm combining like terms because they're on the same side of the equal sign, okay? And then just copy the rest of this, 6x minus 12. And it ends up being kind of what we did yesterday. We have to move the x's to one side and then the numbers on the other side, okay? I personally like to do the positive x values. So if I subtract 7 over here, that's 6 minus 7 is going to give me a negative. I don't want that. So I'm going to subtract the 6 on this side instead. So we'll subtract 6x to this side. And then those cancel. 7 minus 6 is going to be 1. So I just get x plus 2 equals negative 12. And then I need to now get rid of this positive 2 by moving it over to the other side using the inverse of addition, which is subtraction. So then I get x is equal to negative 14. And then don't forget to check your excluded values to make sure your solution is valid. My excluded values are just negative 2 and 2. My answer is not either of those, so this is a valid solution. Okay. And I know it kind of seems like a waste, I guess, to be checking the excluded values because it's always been valid. But starting tomorrow, we're going to see that it's not always going to be valid. We'll see extraneous solutions tomorrow. So just make sure you're always checking your excluded values. All right, let's go ahead and try another example together. This is kind of more what your homework is going to look like with the whole numbers. So go ahead and copy this one. 1/3 plus 5 over x plus 2 equals 2. All right, so remember anytime you have whole numbers, you want to put a 1 in the denominator to make it a fraction. All right, then for the LCD, I'm looking at the denominators. So my LCD in this example, look at the denominators. Can I do anything to them? Any factoring, GCFs, dots? I can't do anything, right? So then your LCD, basically you're just multiplying them together. Like in this case, there's no like terms. So you just put them together. That's just going to be 3 times x plus 2 times 1, but the 1 you really don't even have to worry about it. It's just 3 times x plus 2. Then for the excluded values, remember you're trying to figure out when would the denominator be 0 by making each part of the LCD equal 0. So in this case, I have the 3. If I make that equal to 0, I can't really do anything. I don't have an x, so that doesn't make any sense. 3 does not equal 0. So there's no excluded value for that one, okay? But for this x plus 2, I'm going to switch the sign so that x cannot be negative 2, okay? So my excluded value, my x cannot equal negative 2 at the end. All right, and just like we did on the last example, we're going to multiply by the LCD. This one has 2 fractions, so I'm going to put it in brackets. I'm multiplying by 3 times x plus 2 over 1. Multiply by 3 times x plus 2 over 1. All right, so for the first one, remember you're kind of ignoring the second one for now. You're just looking at the 1/3. The 3 is going to cancel with this 3. So that 3 is gone now. So I'm left with x plus 2 and a 1, which is basically just going to be x plus 2. Okay? So this, I'm done with this now, so ignore it and look at the second fraction. My x plus 2 is going to cancel with this x plus 2. So I'm left with 3 times 5, which is going to give you 15. Okay? And that 15 is basically the 3 times the 5 that was left over when you cancel the denominators. And then on the other side, I have a 1 in the denominator, 1 in the denominator. So I can't cancel anything out of the denominator. So I'm left with 2 times 3 times x plus 2. So 2 times 3 would give me 6 times x plus 2. And, and then kind of like we did on the last example, we need to combine our like terms. In this case, I have a 2 and a 15 on the same side. So that's going to be x plus 17 equals, then you distribute. 6 times x is 6x. 6 times 2 is 12. Okay? And I want you guys to go ahead and practice solving this one. So move the x to one side and then move the numbers on the other side. So I'm going to have you guys solve for x here. Practice doing that. All right, so for these, what I did was I subtracted x. That gave me 5x. And then I subtracted the 12. So 17 minus 12 gives you 5. And then now I got the 5x equals 5. So I need to get rid of that 5 by dividing by 5. And I get x is equal to 1. And then don't forget to check your solution. My exclude value is negative 2. That's not negative 2, so this is valid. This is a valid answer, and I get x equals 1. Okay? So that's the last example that I had for you guys. I just wanted to make sure I went over that before you guys tried to do the homework. So you should be able to do the homework now. So your homework is the 5-2. Yesterday you were supposed to do 1, 2, and 4, so today you guys are doing numbers 3, 5, and 6, which that's basically now the full assignment. It's already posted on Google Classroom, so you guys can take a picture when you're done and turn it in. Okay?